Question 8 is quite a nice little question. It's got two parts to it. Part A has a series of very short questions asking us to identify what element we're talking about from some particular information, and then part B is a more complicated, longer, more open question. So I'm just going to quickly go through part A, and then we'll take a little bit more time to go through part B. So let's have a look at part A then. So this question refers to the elements in the first three periods, hydrogen to argon of the periodic table. Select an element from the first three periods that fits each of the following descriptions. First thing to notice is it's really clear. Select an element from the first three periods. Easy to miss, but we don't need to be worrying about anything further down the periodic table. So part 1, the element that forms a 1- ion with the same electron configuration as helium. So helium, second element, has an electron configuration of 2. If this element has formed a 1- ion, it's gained an electron to fill that outer shell. The only element with one less electron than helium is hydrogen, so that is going to be hydrogen. The next one, the element with the highest first ionization energy. So a high first ionization energy means that outer shell electron is very close to the nucleus. It's maximum nuclear attraction because it's right next to the nucleus. So we're going to have our outer shell electron in that first shell. So it's either going to be hydrogen or helium. Question is, which one? We know that the atomic radius decreases slightly as we move across a period because of the increased nuclear charge, and we know that the nuclear attraction increases as we go across a period because of the increased nuclear charge. So helium has 2 protons, hydrogen has 1. The electron is going to be roughly the same distance away because of it's in the same shell, so the answer to this one is going to be helium. Outer shell electron right next to the nucleus in that first shell, and 2 protons holding tightly to it instead of just the 1 proton in hydrogen. Question 3 says the element in period 3 which has these successive ionization energies. So we've got 4 ionization energies there. They're increasing as we go from a 1+ ion to a 2+ ion to a 3+ ion to a 4+ ion, and the key with this one is we are looking for the big jump. So we're going from 700 to 1400 to nearly 8000 to 10,000. So our big jump is here between the second and the third ionization energy, which means that this element must have 2 electrons in its outer shell because we get this big jump when we're trying to take an electron from the next shell down. So we're looking for an element in group 2. We know it's in period 3, so from our periodic table we can see that that is magnesium. Question 4. The element which forms a compound with fluorine that has octahedral molecules. This is kind of one of those that you either know or you don't know. Sulfur hexafluoride, SF6, is octahedral. It's the example that we always use. So the element we're looking for is sulfur. Question 5. An element which reacts with water to form an acidic solution. A lot of people get this one wrong because they remember that sodium, for example, reacts with water, which it does, but when a group 1 or a group 2 metal reacts with water, they form alkaline solutions, they form the hydroxide. The elements which react with water to form a acidic solution are the group 7 elements, particularly fluorine and chlorine, so we can pick either one of those, so I'm going to go with chlorine. Question 6, the element X which forms a compound with hydrogen, XH3, with a molar mass of 34. So we've got a compound here with 3 hydrogens. Each hydrogen wants to share an electron, so we've got 3 bonds. This looks very similar to a compound that we know about, which is ammonia, NH3, but NH3 has a molar mass of 17, so it's not nitrogen. The reason why nitrogen will react with 3 hydrogens is because nitrogen's in group 5, so therefore it needs 3 extra electrons. So let's stick with group 5 and move down to the next element in group 5, which is phosphorus. So if we had phosphorus pH3, then that would have a molar mass of 31 for the phosphorus plus 3 for the 3 hydrogens, which would be 34. So that is what we are looking for. So the answer is phosphorus. So part 7, an element which forms a compound with hydrogen in which the element has an oxidation number of -4. So we know that in most compounds hydrogen has an oxidation number of +1. Therefore, in order for the compound to have an overall 0 oxidation number, we must have 4 hydrogens. So our compound, is XH4. So the one compound that I know that looks like that is methane. The carbon in group 4 would satisfy that criteria. So carrying on with question 8, there's a couple of clues here as to what this question is all about. It says the element which has a density of 1.33 times 10 to the minus 3 grams per centimetre cubed at room temperature and pressure. And firstly, as soon as we see this phrase room temperature and pressure, we're thinking this question is about a gas, because we know that the molar volume of a gas, the volume of 1 mole of gas at room temperature and pressure, is 24 decimetre cubed. And the second clue is just the size of this number, 1.33 times 10 to the minus 3 grams per centimetre cubed for a density. We know the density of water is about 1 gram per centimetre cubed, so this is 1,000 times smaller than the density of water, so it's got to be a gas. So if we look at that, if we multiply it up, if we multiply it by 1,000, then we've got 1.33 grams in 1,000 centimetre cubed, which is a decimetre cubed. So we've got 1.33 grams per decimetre cubed. If I times that by 24, that means I've got 31.9 grams in 24 decimetre cubed. And I know that 24 decimetre cubed equals 1 mole. So the mass of 1 mole of this substance is 31.9 grams, which means its MR is 31.9, which is very close to 32. So I just need to find out which element on the periodic table has an MR of 32. But we have to be really, really careful, because if I just look up the element with an MR of 32, I come up with sulfur. But I've already said this is a gas, and sulfur is not a gas at room temperature and pressure, it is a yellow solid. So I have to look around a little bit more carefully, and I find that oxygen has an AR of 16, but oxygen comes in pairs as O2. So the MR of oxygen is 32, and that is the answer to this question. Part B of this question is a little bit more open, a little bit less structured. It's 5 marks for this part of the question. Let's have a look at how it's structured. It says table 1.1 shows some properties of period 3 chlorides. And if we look across, we've got group 1 sodium chloride, group 2 magnesium chloride, group 4 silicon chloride, 5 phosphorus chloride, and 6 sulfur chloride. It gives us some data on the electrical conductivity as both solids and liquids, and it tells us whether the melting point is high or low. And it says explain the properties shown in table 1.1 in terms of bonding and structure. So our command word is quite clear. It's explain. 5 marks, so a reasonable amount of detail needed in our explanation. In terms of the key information, well, we've got 2 properties that we're going to try and explain. That's kind of leading me towards the structure of my answer. I'm going to talk about the electrical conductivity first, then I'm going to talk about the melting point. If we link it back to what we already know, then this is a bonding and structure type question. So if I have a look at each of these chlorides in turn, sodium chloride is a metal and a non-metal, so that is ionic bonds, and therefore a giant ionic structure. Magnesium chloride, also a metal and a non-metal, so ionic bonds, giant ionic structure. Silicon, phosphorus and sulfur are all non-metal, same as chlorine, so they're all covalent bonds. So the bonding is covalent. Slightly more tricky in that this could be one of 2 structures. It could be a giant covalent structure, or it could be simple molecular. But the fact that the melting point of all 3 of these is low means that we have a simple molecular structure. So basically this question is asking me to explain why ionic compounds conduct as liquids but not as solids, why they have high melting points, and why simple molecular compounds do not conduct at all and have low melting points. So let's have a look at how we're going to do this. We're going to start off with conductivity. And I like structuring my answer, putting a little heading in so I know where I am. So sodium chloride and magnesium chloride consist of ionic bonds, and form a giant ionic lattice structure. See how careful I am with the terminology, make sure we get that exactly right. They cannot conduct as solids because the ions are held in the lattice and cannot move, whereas as liquids the ions can move and carry the charge. So now I need to move on and talk about the other three compounds. So the others are simple molecular structures, so contain no charged particles to carry the charge. And that's pretty much all I need to say on conductivity, but I've only done half the question. Still need to talk about melting point, so let's be clear, we're going to move on and talk about melting point. And what I'm going to say here is the ionic bonds in NaCl and MgCl2 are, and this is where I'm going to compare, I'm going to say they're stronger than the London forces in the others, and therefore require more energy to overcome them, or break them. So the melting points are higher. And that's it. Key things in a question like that really is all about the terminology. Are we talking about atoms, ions, or molecules? Are we talking about ionic, covalent, or metallic bonds? If we're talking about ionic bonds, it's a giant ionic lattice. If we're talking about metallic bonds, it's a giant metallic lattice. If we're talking about covalent bonds, it's either a giant covalent lattice or it is a simple molecular structure. And then it's just a case of linking the structure to the properties in terms of the particles and the bond strengths, as we have done there.